what happens now if there's a reaction of silicon with oxygen? So silicon reacts slowly with oxygen, and they tends to form silicon 4 oxide. And you have studied its formula in your GCSE, that is SiO2. So how silicon is going to react with oxygen? So first of all, it is a very slow reaction. Okay. And silicon in solid state that reacts with oxygen that is in gaseous form and would react to form SiO2, which is in solid state. Okay. So what are the observations? Let's discuss about the observation. The first observation is that white solid is formed. White solid is formed. And second thing that we have observed that it is a slow reaction. Is that clear? Yes, Sultan. Is that clear?
Yeah.
Okay. So now let's move further towards the reaction of phosphorus with oxygen. With oxygen. So what is going to happen? That phosphorus, you remember we have studied about the molecular form of phosphorus when we have to find out its number of electrons to find the melting point, okay? But in the reaction, remember one thing, during the reaction, phosphorus will always be taken in its atomic form, not the molecular form, okay? S- So just remember this.
Okay.
So it is going to form P4O10, which is in solid state, and this is in gaseous form. So now let's balance it. So we are going to, it's 4p. So we are going to put 4 here. It's O2 and it's 10. So I'm going to put 5 here. Okay. So what are the observation? So yellowish white flame, yellow white flame is going to form, is seen. Okay. And then we are going to have the white cloud of phosphorus oxide is formed. Cloud of phosphorus oxide is formed. And then the reaction would be vigorous. This reaction is vigorous. Okay. So a vigorous reaction has been taken place.
Yeah.
Okay. So now this is a reaction of sulfur, oxygen. So sulfur reacts with oxygen and it is going to form sulfur dioxide. Okay, that is in gaseous form, and that is in gaseous form, and that is in solid form. So, what would be the color of the flame? So, the color of the flame, that sulfur burns with blue flame. with blue flame. So this is basically its observation. And one more important thing, this sulfur dioxide would further oxidize, and would be forming in a reversible reaction. So they are going to form sulfur trioxide. Okay. And this is a, now we can balance it like this, and it is going to form sulfur trioxide. And this reaction you have studied in your GCS during the preparation of H2SO4. And there is a catalyst which we are going to use, that is vanadium pentoxide, and pressure temperature is 450 degrees Celsius. Okay, so this is basically its temperature. Done.
yeah,
Then we are going to move further towards reaction of period 3 elements with chlorine. Chlorine. Okay. So let's discuss their reaction. First, we have sodium, then we are going to have magnesium, then aluminium, then silicon, and then we have phosphorus, sulfur, and chlorine, and then argon. So what is going to happen? First of all, let's discuss the reaction of sodium with chlorine. So if we are going to discuss its reaction, so first of all, we are having this test tube, and what we are going to do, we are going to put sodium. Okay, we are going to put sodium. This is sodium. So I have put sodium here, and there is a gas which is present inside, that is Cl2 gas, and it is going to have a greenish yellow color. Okay, so it is going to have a greenish yellow color. We know that chlorine gas is having a greenish yellow color, and when sodium has been put in it, so what is going to happen? So there's a reaction that Na would react with Cl2 in gaseous form, and they would be forming NaCl, which is in solid form. So first we have to balance it. We are going to put 2 here. We are going to put 2 here as well. Okay. So what are the observations? Let's discuss about the observations. So first observation is that NaCl, which is a white solid. So a white solid is going to form. Okay. And then we are going to have greenish yellow gas. So greenish yellow gas, which is chlorine gas, and when it is going to react with sodium, it starts to disappear. So greenish yellow gas, which is chlorine gas, disappears. Okay. And this reaction is also very fast reaction. So we can say that a vigorous reaction is going to take place. So let's discuss about the reaction of magnesium with chlorine gas. So magnesium in its atomic form, in solid form, that is going to react with chlorine, which is in gaseous form, and they are going to form MgCl2. Okay. So this is the reaction that has been going to take place. And what are the observation? So MgCl2, which is a white solid, is formed. is formed, and then the reaction would be quite vigorous. So we can say that a vigorous reaction has been taken place. And what is going to happen? The color is greenish yellow. So greenish yellow gas disappears. Gas disappear. So what is going to happen? Whenever there is a reaction of aluminium with Cl2, it is going to form Al2Cl6. Okay, so let's balance it first of all. Yes, so this is in solid form, this is in gaseous form, and this is in solid form. So what is going to happen that a white solid is formed, and then the reaction would be quite vigorous. So vigorous reaction has been taken place. And what is going to happen? The greenish yellow gas would disappear. Okay.
Okay.
So now we are going to have a reaction of silicon with chlorine, with chlorine. So if we are going to have the reaction of silicon, which is in solid state, and it is going to react with chlorine, which is in gaseous form, they are going to form SiCl4. Okay, and that is in liquid form. Remember, this SiCl4 would be in its liquid form. Okay, so what are the observations? Observation is that silicon reacts slowly with chlorine. So silicon that reacts slowly with chlorine, and what is going to happen? The what is going to happen? Greenish yellow gas disappear. Greenish yellow gas disappear. Is that clear?
Yeah.
Okay, kindly note it down.
Okay.
So now there's a reaction of phosphorus. Phosphorus reacts with chlorine. Okay. So what is going to happen over there when phosphorus reacts with chlorine? It is going, you remember that phosphorus would react in its atomic form. Okay.
Oh yeah.
It is in solid state. So it is going to react and would be forming PCl5, which is in liquid state. Okay. So this one is also in its liquid state. So now what is going to happen? We have to balance it, and this would become 5 and it would become 2. So greenish yellow gas disappear. Observations are that greenish yellow gas would disappear. Okay. and there would be a slow reaction. So reaction would be quite slow. Done?
Yeah.
Okay. So now let's move further towards reaction of period 3 with water. With water. So first of all, let's start with the discussion of reaction of sodium, which is in solid state, and that is going to react with water. So what it is going to form when sodium reacts with water? This is the reaction that you have studied in your grade 11 as well. So what is
Is
that?
it the NaOH?
Great. So there would be the production of NaOH in its aqueous form, and hydrogen gas would be evolved. Okay. So this is in aqueous form, so hydrogen gas would be evolved. I'm going to balance it. So it would become 2NaOH plus H2. I have to put 2 here as well. Okay. And remember one thing, as we know that group 1 elements are quite reactive. They are quite reactive because they have only one electron to lose. Okay. So they are quite reactive because of having one electron in its outermost shell. So sodium, which is the most reactive one in this group, it can react with even cold water as well. React with cold water as well. And the reaction would be quite fast. Okay. So what is going to happen? For example, if this is water, so sodium will come on its surface. Okay, sodium would move across the surface of water. So let's write some points related to it. Sodium would move across the surface of water. Okay, and then what is going to happen? Sodium quickly gets smaller until it disappears. So sodium quickly gets smaller in size until it disappears. Is that clear?
Yeah.
So it quickly disappears after reacting with water, or you can say even dissolves in water. It dissolves in water. And what are the observation that fizzing or bubbling occurs due to hydrogen gas? So fizzing or bubbling occurs due to hydrogen gas. Is that clear?
Yeah.
So what would be the pH of the solution? Remember, sodium hydroxide is strongly alkaline. This is strongly alkaline. Okay. And if it would be strongly alkaline, its pH would be 14. Is that clear? So
Yeah.
pH of solution would be 14. We know on pH scale, you are quite familiar on pH scale. This is 7, which is for neutral. Okay. So if you are moving towards 7 to 1, it would become strongly acidic. And if you are moving from 7 till 14, it would become strongly alkaline. Is that clear?
yeah,
So, and remember one thing, this sodium hydroxide is quite soluble in water. So what it is going to do, it is going to be broken up into its ions. It would become NaOH and would be doing Na positive plus OH. So it is going to break up into ions. Is that clear?
yeah,
So if we want to discuss about the reaction of magnesium with cold water, remember, like sodium reacts very fast with cold water, but opposite is the case with magnesium, as magnesium is less reactive than sodium because magnesium belongs from group 2. Group 2 elements, they are basically less reactive than group 1 metals. Okay, so magnesium reacts with water and it is basically a cold water. So what is going to happen, it is going to form magnesium hydroxide with the production of hydrogen gas. One important thing that we have to memorize here, first of all, let's balance it so it would become like this. The important thing that we have to memorize here, that this reaction is quite slow. Okay, as magnesium is reacting with cold water, so this reaction is quite slow. The reason is that magnesium is less reactive. Magnesium is less reactive than sodium. Okay, than sodium. As Na reacts with cold water very fast. Magnesium is less reactive than sodium, so that is why sodium reacts very fast with cold water. The second thing that we have to see, that magnesium ionization energy is quite high, is high as compared to what? Sodium. As compared to sodium. You must know this thing, that ionization energy plays a very important role in the reactivity of our metals. As ionization energy is the energy required to remove the electron from the outermost shell, okay, of an atom. So its ionization is quite high. So high energy is basically required to remove its outermost electrons. The reaction is quite slow, that it even take days to fill hydrogen gas. Is that clear?
yeah,
So that is why we would say that reaction would be very slow. And this other thing is that solution form is weakly alkaline. Remember, this magnesium hydroxide is weakly alkaline with a pH of 11. Okay, so solution form is weakly alkaline. Okay, and magnesium hydroxide is basically slightly soluble in water. I have told you that group 1 alkalis would be more soluble in water, but magnesium hydroxide would be less soluble in water, and it is basically less soluble in water. So you can say slightly soluble in water. In water. And it's basically weakly alkaline. It is going to be split up into ions like magnesium plus 2 OH minus. So now what we are going to do, we are going to study about the reaction. We know that magnesium reacts slowly with cold water, but if magnesium has to react with hot water, what is going to happen? Okay, this is a very important difference. So here magnesium is reacting with hot water, which is in gaseous form, and it is in solid form. So when it reacts with hot water, or you can say steam, then magnesium oxide is formed instead of hydroxide with the elimination of hydrogen gas. So this reaction would be very fast and vigorous as well. Is that clear?
Yeah.
Now, let's move towards the next topic, and that is oxides of period 3 elements. So if we are discussing about oxides of period 3 elements, what is going to happen? This is sodium, this is magnesium, then we have aluminium, then we have silicon, and then we have phosphorus, then we have sulfur, and then we have chlorine. Okay, so their oxides are, it has the oxide of sodium oxide, it has magnesium oxide, it has aluminium oxide, it has silicon oxide, and it has phosphorus oxide, P4O10, and it is going to have sulfur dioxide that we have discussed, or sulfur trioxide, and this is going to have chlorine oxide, okay, chloroxide, you can say. So reaction of sodium oxide with water. Okay, so sodium oxide is going to react with water in solid state. So it is going to react with water, okay, which is in liquid form, and it is going to form sodium hydroxide. Okay, so it is in aqueous form. So it is going to form sodium hydroxide. And remember, it is strongly alkaline. It is strongly alkaline. We have already discussed with the pH of 14. So now magnesium oxide that reacts with water and would be forming magnesium hydroxide, which is weakly alkaline, okay, weakly alkaline with a pH of 11, okay. So this is in solid state, and this is in liquid state, and this is in aqueous form. Now, there is an important use for magnesium oxide and magnesium hydroxide, that they are basically used in indigestion tablets, okay. So
Okay.
might have seen the tablets which are basically used to remove acidity. That magnesium oxide uh, or magnesium hydroxide is basically used in indigestion tablets. So what is going to happen? Magnesium oxide, when reacts with HCl, it is going to form magnesium chloride like this, with the production of water as well. Okay, so this is basically in aqueous form. This is in liquid form. This is in solid form. This is in aqueous form. Okay, so, or magnesium hydroxide. Let me write the reaction for that as well. That is also going to react with HCl, which is in aqueous form, and would be forming magnesium chloride in aqueous form with the production of water as well. So let's balance it. So we are going to put 2 here, and we have to put 2 here as well. Is that clear?
Yeah.
Okay. So, the important thing that I just want to tell you is sodium oxide, Na2O. We know it reacts with water and would be producing 2NaOH. But how it is producing? In this sodium oxide, we know it is Na positive and O minus 2. So what is happening here, that O minus 2 here is basically acting as a base. Why it is acting as a base? We know that H2O is composed of H positive, which is having partial positive charge here, OH with having partial negative charge here. So as it is more electronegative, so what is going to happen? The electrons would be pulled till this point and this bond is going to break. How it is going to break? Heterolytically. It is going to have heterolytic fission. Okay. So that is why it is going to break. And then what is going to happen? This H positive would move towards O minus 2 and it is going to produce two OH ions. Is that clear? So
Yeah.
in this one, basically O minus 2 is acting as a base, which has been taken by this, you can say H positive ion, okay, or you can say that electrophilic substance, and it would be added here, and it is going to make a bond of OH. So I hope this point is clear to you. And after this, let's move towards aluminium oxide. Remember, aluminium oxide is insoluble in water. Okay, insoluble
Okay.
in water. And I have told you before that aluminium basically, surrounding aluminium, there is a coating of aluminium oxide that has been formed, and that would stop the further reaction with oxygen. So, aluminium oxide layer is formed surrounding the aluminium. So then what is going to happen? Aluminium oxide, we have discussed it in our grade 11 that it is basically an amphoteric oxide. Do you remember? Amphoteric oxide. So amphoteric oxide,
I don't know what this is actually.
okay, let me tell you, amphoteric oxides are those oxides which can react with both acid or base to form salt and water. Is that clear? To form salt and water. So it is basically,
Okay.
you can say, the unique property. And then what is going to happen around there? Like, for example, you can see this aluminium oxide that can react with sulfuric acid, which is an acid, and it is going to form aluminium sulfate, SO4 3, plus the production of hydrogen gas. Oh, sorry, plus the production of water would be there. So let's balance it out, and it is going to form this 3H2O, okay, and it would be a base. It is reacting here like a base. Kindly note it down. So aluminium oxide that is basically reacting with this acid, which is in aqueous form, and would be forming aluminium sulfate, okay, which is also in aqueous form and it is in liquid form. So let's balance it. There are three sulfate ions, so I'm going to put three here, and that is why I have to put three over there as well. So when aluminium oxide reacts with base, so let's consider the reaction with base as well. So what is going to happen? When aluminium oxide reacts with sodium hydroxide, so it is going to form sodium aluminium hydroxide like this. Is that clear?
Yeah.
And it also reacts with water as well here. So this is its reaction with base. Aluminium oxide reacts with sodium hydroxide with water, and they are going to form sodium tetrahydroxyaluminate. So let me just write its name. That is sodium tetrahydroxyaluminate. Is that clear?
Yeah.
And its structure would be somehow like this. Sodium is basically present outside, and aluminium would be here with four OH groups that are pointing towards aluminium like this, and this is OH would be like this. So what is going to happen around there? That sodium would be at this place. Is that clear? With the positive.
Yeah.
Okay. What about SiO2? So SiO2 is insoluble in water. Same is the case with aluminum oxide. Aluminum oxide is also insoluble in water. So silicon dioxide is insoluble in water as well. So SiO2 is acidic in nature. Okay. So silicon dioxide is basically acidic in nature, although we know that metal oxide, they are basic, and non-metal oxides, they are acidic. But as we know that silicon is a metalloid, so its oxide is also acidic. Okay? It reacts with
Okay.
it reacts with sodium hydroxide and would be forming sodium silicate in aqueous form, and then there is production of water as well. Okay, which is in liquid form. So this is in aqueous form, this is in liquid form, and this is silicon dioxide, which is in solid form. So they are going to form this salt, which is sodium silicate. Okay, and this is in
Okay.
aqueous form. Yeah. So this is basically its equation. Now let's move towards phosphorus oxide. P4O10 is soluble in water. Is soluble in water. So P4O10 reacts vigorously and dissolves in water and dissolves in water to form acidic solution of H3PO4. Okay, so this is the acidic solution they are going to form. So that would be P4O10 and would react with water and would be producing H3PO4. Is that clear? So
Yeah.
this is the acid that they are going to form in aqueous form, and this is a strong acid, phosphoric acid, with a pH of 2. Okay, this is in liquid state, and we have to balance it. For that purpose, what we are going to do, we have to put 4 here. Yes, we have to put 4 here, and we are going to put 4 3s are 12, so we are going to put 6 here as well. I hope it's, yes, it's balanced now.
Yeah.
So let's move further towards oxides of sulfur. So oxides of sulfur, or you can say sulfur dioxide, or you can say sulfur trioxide. Both react and dissolve in water. So they both react and dissolve in water to form acidic solution, to form acidic solutions. So then that would be SO2 gas plus water, and they would be forming sulfurous acid. Okay. And this sulfur trioxide also
Yeah.
reacts with water and would be forming sulfuric acid. Okay. So this is basically
Yeah.
sulfurous acid, and this is sulfuric acid. Is that clear?
Yeah.
Okay. This is all about our today's lecture. If we discuss about relative melting point, so sodium oxide, as it is a metallic oxide, so it would be high. And for magnesium oxide, it's also a metallic one, so it would be high as well. For Al2O3, it's a metallic one, so it is very high. Why their melting point is basically increasing? Because of the charge. Sodium is having +1 charge, magnesium is having +2 charge, aluminum is having +3 charge. Then silicon dioxide with a giant covalent structure, so that would be very high as well. But for phosphorus oxide, it turns out to be low. And for sulfur dioxide, it is low as well because they are non-metal oxides and they are having weak intermolecular forces. So if we discuss about electrical conductivity, so this is good because it's metal, good, and aluminum oxide is good as well. While in silicon dioxide, which is having covalent bond between them, so it is not going to have any kind of electrical conductivity. So phosphorus oxide, non-metal oxide, so it is not going to have any electrical conductivity. Same is the case with sulfur dioxide as well. So let's move towards the chemical bonding. If we discuss about the bonding of sodium oxide, so we can see that it is going to have ionic bonding because one is metal and the other one is non-metal. So it's going to be a ionic bonding. Same is the case with magnesium oxide. It's also going to have ionic bonding. But for aluminium oxide, because of the difference in electronegativity, it would be having ionic with some covalent properties. And for silicon dioxide, it is going to be the covalent one. And for phosphorus oxide, same covalent. And for sulfur dioxide, it's covalent as well. So now let's discuss about structure. In structure, we are going to see either simple or giant. So we know that sodium oxide being a metallic oxide, so it is going to have a giant ionic structure. So same is the case with magnesium oxide, a giant lattice structure or ionic structure. And this is also would be having giant lattice structure or ionic structure.
But for this one, it is going to have a giant covalent structure. It is going to have the simple molecular structure. And this one also going to have the simple molecular structure. Is that clear?
Yeah.
So we have to memorize this thing. So have you noted? Can I move further?
Just one second.
Oh, so just like let's discuss about some of the uses of magnesium oxide. So we know that due to high melting point of magnesium oxide and aluminum oxide. Okay, so magnesium oxide is used for inside lining of furnace. We know that the furnace, uh, in the furnace, there is basically different kind of reaction that has been taken place. So the reaction, they basically take place at quite high temperature. Okay. So inside lining of this furnace, that is basically made up of magnesium oxide. That is made up of magnesium oxide. And the reason is that magnesium oxide has a very high melting point. Is that clear?
Yeah.
And then let's move towards aluminum oxide. If you want to discuss about aluminum oxide and silicon dioxide, they are they both are basically used to make ceramics. Okay, we know like the washroom utensils, they are basically made of up of aluminum oxide and silicon dioxide. The other use is that they are basically also used for the purpose of electrical insulation. Okay.
Yeah.
So now our next topic is effect of water on chlorides of period 3 elements. First is sodium, then we have magnesium, then we have aluminium, then we have silicon, phosphorus, and sulfur. Sodium is NaCl, its chloride is MgCl2, it would be Al2Cl6, and then there is SiCl4. Then we have PCl5, and then we have SCl2. So oxidation states are +1, +2, +3, +4, and this is +5, and this is +2. Okay, so these are the oxidation states.
Okay.
When we are putting NaCl in water, what is going to happen? It is going to break into its respective ions. Sodium, however, that is basically surrounded by 6 oxygen atoms, and they are arranged in this form. And we know oxygen is having partial negative charge. So there is an other oxygen at this point, partial negative charge. This other oxygen at this point, which is having partial negative charge, and other oxygen here, which is having partial negative charge. So 1, 2, 3, 4, and there is 5 as well, which is at this point. partial negative charge. 1, 2, 3, 4, 5. And then we are going to have at this point, that is partial negative charge. Okay. Then what is going to happen? Like if we consider about Cl, in the same way, Cl is also surrounded by six pair of hydrogen atoms. Okay. So what would be the six pairs would look like? So that
Yeah.
would be at this position. Okay, so I'm talking about six pairs. It's having partial positive charge, partial positive. Now in the same way, it is going to have like this, partial positive, partial positive. Then we have like this, partial positive, partial positive. Okay, so 1, 2, 3, 4. H. Okay, so you can see that basically a chloride ion has been surrounded by, this is partial positive, has been surrounded by six pair of hydrogen atoms. Okay, so let's discuss about MgCl2. So it is going to be split up into its ions when they are going to put it in water. So that would be 2Cl minus. Okay, so this is in aqueous form. This is also in its aqueous form. So let's discuss about Al2Cl6. First of all, if we are going to add water in it, so if we are adding water, then what is going to happen? This Al2Cl6 would be converted into AlCl3. Is that clear?
Yeah.
And this AlCl3, so in water, that would be converted into its ions in this form, plus 3Cl negative. Is that clear?
Yeah.
Okay. So now let's move towards reaction of SiCl4 with water. So what is going to happen? This is SiCl4. It is going to react with water in this state. So they are going to form SiO2 plus 4HCl. Okay, so I'm going to put 2 here. This is in liquid state. We have discussed it already that SiCl4 would exist in the liquid state. Is that clear?
Yeah.
So that is also in liquid state, that is in gaseous state, and that is in aqueous form. Oh, sorry. HCl here, that would exist in its gaseous form. Okay, and SiO2 is always in its solid form. Okay,
Okay.
so here the pH would be equal to 2. Why? Because of formation of HCl, of HCl. And what are the observations? So observations would be white fumes are produced. Okay. And the second observation is why white fumes are produced due to formation of HCl. Okay. Because of its formation only, the white fumes are going to be formed. The second is white precipitates are formed because of, they are formed because of SiO2. Okay.
Okay.
Now we are having the last reaction, that is reaction of PCl5 with water. So this reaction states that PCl5, when they are reacting with water in liquid state, so what is going to happen? This is in solid form. So HCl is going to form here, which is in gaseous form, and then phosphoric acid is going to form as well, which is in its aqueous form. So white steamy fumes are formed. White steamy fumes form due to HCl. Due to HCl. Is that clear?
Yeah.
Okay, kindly note it down, please.